One of the main consistencies of the One Piece series has been the vast world building that Ichiro Oda continues to masterfully craft. A driving factor of that is none other than the breadth of characters that we're continuously introduced to. If you're interested in uncovering insights into the nature of character appearances within the One Piece series, stick around. X and I got some cool tricks for you. What's good, YouTube? It's your boy Taichou. That's X. We're jumping right into it. So in our prior video, we took the time to synthesize and write a query to help us do analysis on the data that we worked so hard to web scrape in our prior videos. So now it's actually time to get to that analysis. So for this analysis, I've decided to use a new dog gibbous. That's going to be the statistical language R. I'm okay with R, but I thought it'd be a fun little switch up to do the analysis here. And what I've done is I've kind of broken things out as usual into different steps. So we're just going to kick off captain's orders. So the first step I have is basically to bring in our packages. I have them here because I don't want to spend too much time going over them. But basically, these packages are going to enable us to query the data in the SQL Server database. And then from there, it will allow us to do some data manipulation to get the data in a format where we can make some cool visuals in our exploratory data analysis, and then format them appropriately. So those are the main. I'll go over the packages when we get to that. The next step after that is, of course, we need to establish our connection and import the data. Following that step, we're going to be formatting the data using piping. Piping is really cool in R. It's an awesome way to have kind of like procedure set up with working on the same data frame so that you don't have to constantly continue to reference it. Basically, we're going to be doing, maybe some filtering and collapsing there. And then after that, we're going to create our first table and visual. So what we want to do is answer, quote unquote anime questions like how many characters appear in a chapter, and what does that distribution maybe look like over time? Is there a certain number of named characters that you can expect? I think that's a cool stat to have. So we'll work on gaining those types of insights. And then from there, we'll look at the actual character appearances, which characters appear most often in One Piece, see if we can get any insights there. And then finally, let's, check out the sagas, see if there's any trends around the saga, number of unique characters that we see in a saga, how they compare to other ones. And to do that, we're going to have to merge a couple of data frames that we created. But yeah, that's on the agenda for captain's orders. So without further ado, let's get right into it. Starting off with step 0, packages. So we have 5 packages up here. Probably actually only need 4 for this part of the analysis. The 5th one will come in the second part. But for this first part of the analysis, we're going to be working with tidyverse. Tidyverse is what we use to clean the data. I'll leave it at that. I don't want to go too deep into it. From there, we have LuberDate. LuberDate allows us to manipulate dates and times if you're looking at time series. RODBC, that is what enables us to establish a connection between R and SQL Server. And then ggplot2 and grid extra for creating nice clean visuals and arranging them appropriately. So X, using our new dog Jupiter, if you could give us the R script to establish a connection to the SQL Server, that would be great. Cool. So here we go. I'm going to have a variable called dbcon, and we're going to use this function odbcconnect. Basically, this is establishing our connection and allowing us to query SQL Server. In order for this to work, you have to have a driver set up. I'm not going to really talk about that. You can Google how to set up your driver appropriately so you can do so. So after you establish our connections, similar to prior videos, it's, we establish our connection and then we can actually query. In our prior ones, what we were doing was exporting data from Python that we web scraped into SQL Server, but in this video, we want to import the data that we've synthesized in our prior video, which you can check out here. So to do that, X, if you could give us 2 lines that establishes 2 data frames, and to query the view that we created in the last video as well as the character appearance video. Awesome. So here we go. Here are 2 lines. We're creating df and df0. These are going to be data frames, and you can see here the SQL query. We're querying this connection that we've established, and here are the queries. So we're select star from the character appearance table, and then we're select star from the chapter arc saga details view that we created in the last video. This last part here, string as factors equals false, basically means not to bring in or automatically turns variables into what's called a factor class. It's a leveled variable. So if you think about all the sagas, we have 11 sagas. R would consider each row a different level, but we don't want to work with factors, so we denote that as false. So I'll stop there and I'll run this. So basically, we bring in our packages, we establish our connection, and then we create 2 data frames. So these data frames, which we can see here, df0 has 30,165 rows, the exact same number of rows in the character appearance, and then df0 has 1,088 rows, which is the exact same amount of rows in the chapter arc saga details. So we know that worked correctly, and we can take a peek at the data. It looks exactly what it looks like in SQL Server, so we know we're on the right track here. So step 2 now, we're going to do some table formatting. Let's see. So what I noticed when I was doing this analysis was that there were some inconsistencies with some of the fields in there, and as I mentioned in the last video, and we could see here, we have kind of like groups brought in, like pirates, and then we also have village, pirates again, that's groups, others, things like, characters that may not exactly be characters. So I'm going to ask X to give us a quick line to create what's known as a vector of, there it is. So here's a quick line. Basically, these are going to be things that we want to exclude from our analysis. So we put them all in this, what is known as a vector, denoted by this C thing, and we put it in a variable called non-characters. The next thing that we want to do now is, really quickly, Trafalgar D Law, honorary straw hat. X, if you give us a line that cleans his name, essentially his name is showing up twice, but two different versions. So let's see if I can highlight what that means. So you see Law, Trafalgar Law, and then you see Trafalgar the Water Law. So basically, we just want that to be one. Cool. So here's the script for that. And what I'm doing is, here's the quip pipe. So we have our df data frame, and basically all I'm using is this mutate function, which allows me to manipulate that column. I want to change the character column so that if the character equals Trafalgar Law, change that to Trafalgar D Water Law. Otherwise, keep the character but trim the white space. So this should stay essentially the same count, but we should only see one version of Law's name. Let's run that. So okay, so now we can see the names of Trafalgar only being his full name, which is what we want because we don't want to kind of misrepresent the number of unique characters that we see. So we've set up those two variables and we've removed that. So the next step that we want to do is actually create our first table that we're going to, kind of like our first aggregation table. We want to count the unique number of characters that appear per chapter. So to do that, X, if you could give us piped group by of the chapters, counting the appearances, that'd be awesome. Cool, so here is what that part looks like. Let me remove this. Number of characters per chapter. So I'm creating a chapter character variable and using the df, the data frame, and I'm making them one-to-one. So essentially, first step, it's the same thing. But then I'm using this pipe, which allows me to do additional processes on that. I want to filter out the non-characters. So if there is any text that contains these words, it's going to filter that out. So this number here should be lower. And then I want to group by the chapter. So we should only have we should have 1088 rows, but I want a count. So I'm counting n, and since we know n is a character, it's counting the characters that appear, and then we'll arrange that in descending. So let's run that. Cool. And so here's chap chart. We have, as I mentioned, 1088 rows with two variables, and this is what that looks like. Chapter appearances. So right off the bat, chapter 1053 has 90 characters appearances. 801 has 80. I don't know exactly which arcs these are. Well, I know this is probably the end of Wano or Egghead. I'm not exactly sure. This looks like it's Whole Cake Island. This is probably Impel Down or Marineford. This is probably Fishman Island. This is, I believe, Levelly, and so on and so on. But yeah, so here's our first aggregation table. And what we want to do is just get an idea of what the distribution looks like. So X, if you can give us the script to create a histogram so that we could see, roughly how many chapters have X amount of characters. So here's the script. This is using the ggplot package that we brought in. So first thing, this outer parentheses around the scripts means to automatically produce the plot, so I don't have to call it. I'm calling it hist. I'm using ggplot. Reference the chapchar table that we created. Aesthetics, basically denoting the variables that we want to measure, and we want to measure the appearances. I just want to put a red border so that the bins are a little bit more distinct. And then we tell ggplot what type of visual we want, and we want a histogram, so we use gm histogram. And then from there we just want it to be somewhat professional looking. So we use GG title. I'm going to call it the number of chapters based on unique character appearances, 1 to 1088. We'll call the x-axis the unique character appearances, and then we'll call the y-axis the number of chapters. So what we're doing in here, we're counting the number of chapters, and we're counting them based off of how many characters appear. And so let's get a look at that. Cool. So here we have our first plot. This is the number of chapters based on unique characters. So you kind of see that it's relatively skewed to the right, meaning that as the number of character appearances increases, we have less chapters that fall into those categories. So the data falls to the right. And then you can see like the most of the volume, number of chapters over 100, occurs between I would say 12 and 25, or I would even say 12 to probably 45 or so. But what we can do to get a little bit more accurate stats on that, we can just call the summary. So X, if you give us the summary, and this is what that'll look like, we can run that. Boom. So here's our summary for this histogram. The minimum character appearance is 3, so there's chapters where we only see 3 characters. There's chapters where we see 90 characters, and then on average you can expect in a One Piece chapter drop to see between 20 to 25 characters, which I think is pretty insane. I think it speaks to the world building that Oda does, the expansiveness, and it's a series that's been going on for 26 years, so it's not too surprising after all the introductions to see 20 to 25 named characters per chapter. So I think that's a pretty cool insight. In the interest of time, I'm going to cut this video short. I hope you're enjoying it. If you are, smash the subscribe button, leave a like. What other insights are you guys interested in? I'd love to get your feedback. But until next time, Taichou out.